Alright, let's look at some work that we've been doing in class this week. Remember, we started talking last week about converting numbers between scientific notation and standard notation. Remember, the first thing before we do this, we have to make sure every time we work with these that the numbers we are working with are in correct scientific notation. Remember, to do that, our coefficient must be greater than or equal to 1, but must be less than 10. Okay? So remember, we talked about our coefficient. If we look at a number like 2.6 times 10 to the third power, remember the coefficient is the number in the front. Okay, so if we're looking here, this number 2.6, it is bigger than or equal to 1, and it's less than 10. Also, there's only one number in front of the decimal. So make sure we look at that first. Remember, your base must always going to be 10. It's always going to be 10. So here my base is 10. And then remember, my exponent tells me a couple of things. It tells me which way I'm going to move my decimal to and how many places. Remember, if it's positive, I'm going to move it to the right. If it's negative, I'll move it to the left. So in this case, if I was to take this number, and if I was just to go ahead and convert this number from scientific notation into standard form, this 3 tells me to move my decimal 3 places to the right. All I'm going to do is take it from where it's at. It's between the 2 and the 6 right now, so here's 1. And since I've already moved it 1, let's add 2 more zeros. So 1, 2, 3. So 2.6 times 10 to the third power is actually 2600. What you're looking at is 2.6 times, and remember 10 to the third power is 1000. So it's 2.6 times 1000 would give me 2600, which is a little simpler if you just look at this instead of trying to multiply those numbers out. Okay, let's just do a couple more. Let's say if I have something like this number, let's say 0.0, well, let's do an easier, let's do a positive one again first. What if I have 2.94 times 10 to the fourth power? So again, I'm going from scientific into standard, so this number tells me 4 places to the right. So just move my decimal 4 places to the right. So if I look, if I write my coefficient, I've already got it moved 2 places. So 1, 2. I've got to move it a total of 4, so just add 2 more zeros. 1, 2, 3, 4. So 2.94 times 10 to the fourth power is equal to 29,400 in standard notation. So you're just moving it back and forth. All right. Let's look. What if I do something like this? What if I have something like 2? Let's get away from the 2's. What if I have 7.43 times 10 to the negative third power? I want to take this guy from scientific and put him in standard. Well, this time I have a negative exponent, which is going to tell me to move it to the left 3 places. So take my decimal, 743. Right now it's behind the 7. If I move it in front of the 7, that's 1 place, 2 places, 3 places. So 1, 2, 3. That's your decimal. So 7.43 times 10 to the negative third power is the equivalent of 0.00743. Just move your decimal whichever way it wants you to go. Alright, let's go the other way. What if I have a number, let's say 9,468? I want to take that from standard form and put it in scientific notation. Well, this is where we got to watch, because it's kind of backwards. It looks backwards to you, because right now your decimal is here. So remember, my first rule was I can only move it to where I can only have one number in front of the decimal, or my coefficient has to be greater than 1 but less than 10, or excuse me, greater than 1 or equal to 1 but less than 10. So if I follow those rules and I move it right here, now I only have one number in front of the decimal. It's bigger than or equal to 1, but it's less than 10. Okay, so now 9.468. Remember, my base is always going to be 10. All right, and since this number is bigger than 1, my exponent is going to be positive. So let's just count. How far is it from this decimal? 1, 2, 3. So 9.468 times 10 to the third power. All right, I'm going to give you one. I'm going to leave this up here, and I want you to try it. I want you to pause the video and see what you can do with it. What if I was to give you 396? All right. pause the video and then try to do it, and then come back and see what you get for your answer. Alright, welcome back. Hopefully you have taken your decimal, it started here, and you know it's got to be put somewhere to where there's only one number in front of the decimal. Well, that would be between the 3 and the 9. So my coefficient is 3.96 times my base is 10, and since I moved it 2 places, and my original number was bigger than 1, so that's going to be a positive exponent. So 396 is equal to 3.96 times 10 to the second power in scientific notation. Alright, how did you do? Alright, let's try one more. You try this one and see what you come up with. One more time, stop your video, and then you try to figure it out. What if I give you something like 2, 0, 4, 1, 0, 0. Okay, pretty big number. Stop the video and you try it on your own. Okay. Alright, let's see what you got. So remember, this one is here because it's understood to be at the very end of a whole number. And then I need to move it somewhere right in here because I have one number in front. So if I write this out, remember we write all of our numbers out to the last non-zero number, which means I don't have to write these two. Nothing wrong with it if you do, but you don't have to write the 2 zeros. So my base is going to be 10. Now how far did you move it? 1, 2, 3, 4, 5. So 204,100 in standard form is equal to 2.041 times 10 to the 5th power in scientific notation. Alright, let's go the other way with this thing. What if I try to smaller than? What if I have something like 0.0375? That's a small number, so automatically I know, we talked about this, I know my exponent is going to be negative, but let's kind of figure it out. We need to move our decimal to where there's one non-zero number in front of the decimal. So if I move this thing, if I put it here, there's 2 numbers in front, but also 37 is much bigger than 10, so I can't put it there. So we're going to have to put it right here, between the 3 and the 7. Now I have one number in front, so now I can write my coefficient, 3.75 times 10, then since it's smaller than 1, I know my exponent is going to be negative. Now let's see how far. 1, 2 to the negative second power. Alright? Let's do one and you pause the video and you try it. So 0.39401. Alright? Pause the video and you try it. Alright? Let's see what you did. So my video was paused for just a second. Now I started it back up. Now let's see what we have. So my decimal is here. I need to move it to where there's one number in front. So I'm just going to move it right there. So my coefficient is 3.9401 times 10. And since this original number was smaller than 1, I know I have a negative exponent. How far did I move it? One place. To the negative first power. Alright. So 0.39401 in standard form is the same as 3.9401 times 10 to the negative first power. Alright? Let's do a little operations with it. Let's try a little multiplication now. Most of you have your calculators, and if you have it, that's great. If you're not, we can do it without a calculator. Let's take a number, let's say something like 3.2. Let's just do an even. Let's do a whole number first. What if I have something like 3 times 10 to the 6th times, well, let's don't use the x because that's kind of confusing, times 2 times 10 to the 4th. And remember, this is what we did all of a couple weeks ago. All we're looking for here, I have coefficients. Remember, I can rewrite this as 3 times 2 and then 10 to the 6th times 10 to the 4th. You don't have to rewrite it, but it will help you. So all I'm doing here is I'm multiplying my coefficients. 3 times 2 is 6. And if I'm multiplying the same bases, right now here's my coefficients, I'm sorry. I'm going to multiply. In here I have the same base of base 10, so that means if I'm multiplying the same bases, I'm going to add my exponents. So I have times 10, and 6 plus 4 is 10. So my answer of 3 times 10 to the 6th power times 2 times 10 to the 4th power gives me 6 times 10 to the 10th power. Okay? So this is your final answer. So all you're doing is multiplying the coefficients, and adding your exponents. Now the last thing, this is incorrect scientific notation because it's bigger than 1, equal to 1, but less than 10. And if you'll look, my decimal is actually right here. There's only one number in front. Okay? All right, I'm going to give you one. You try it real quick. Let's see what you have. Let's go 2 times 10 to the 8th power times, let's see, 4 times 10 to the 11th power. All right, pause the video. You come back and you try it. Let's see what you get. All right, so let's do this without rearranging. We can say here 2 times 4, so we're going to multiply our coefficients. Excuse me. And we're going to add our exponents because my bases are the same. So 2 times 4 is 8 times 10. 8 plus 11 gives me, excuse me, that's a plus sign, 8 times 10 to the, 19th power. Now that's a really big number, so we're not going to try to solve it out. But here again, I know my coefficient is right because there's only one number in front of the decimal because the decimal is understood there. Base is 10, and I have an exponent. So if I was to try to do this, I could really work this out. All I do is add 19 to 0 because my decimal is here. So just keep adding zeros until you get 19, and that'll be your answer. Okay. Let's try one where we have to do a little of adjusting of our coefficient and our exponent. What if I was to do something like 6 times 10 to the negative 4th power times 5 times 10 to the 12th power. All right, same concept. You're multiplying your coefficients. And we're going to add the exponents. Remember, we can rewrite this again as 6 times 5, coefficients in 1, times 10 to the negative 4th times 10 to the 12th power. Same thing. You're multiplying your coefficients, adding your exponents. So 6 times 5 is 30 times, bases are 10, keep the base, and add your exponents. Negative 4 plus 12 is 8. But if I look right here, 30 is bigger than 10. It is greater than or equal to 1, but it's also bigger than 10. But if you look, your decimal is here, and I have 2 numbers in front of the decimal, and I can't have that. So what I have to do is I have to adjust my decimal by moving it 1 place to the left and adding 1 to my exponent. So my final answer is 3, and you can write 3.0, it doesn't matter. I just choose not to write it, times 10 to the 9th power. And that's all you're doing with these problems. Now we are in correct scientific notation and we're good to go. Alright, let's look at a division problem. What if I was to give you something like 24 times 10 to the 12th power divided by 12 times 10 to the 6th power. Well, this goes back to what we did before where we have the same bases, we're dividing. Okay, and we have coefficients, so we can rewrite this as 24 divided by 12 times 10 to the 12th divided by 10 to the 6th. So if you remember what we're doing here, coefficients, we're going to divide, and now since I'm dividing, I'm going to subtract my exponents. Alright? So here we go. 24 divided by 12. All I do is rewrite it. 24 divided by 12 is 2 times 10 to the 12 divided by 10 to the 6 is 10, 12 minus 6. Numerator exponent minus denominator exponent. So my final answer is 2 times 10 to the 6th power. Now we can actually do this one because what it wants to do is, this is a smaller number we can fool with. So 2, and since my decimal is here, I need to move it 6 places. Let's just add 6 zeros. 1, 2, 3, 4, 5, 6. Let's count. 1, 2, 3, 4, 5, 6. So my answer is 2 million. So 24 times 10 to the 12th power divided by 12 times 10 to the 6th power gives me this number in scientific notation and 2 million in standard form. So all you're doing is the same concept we did last week when we were working with our exponents. Let's try one that you need to try, and I want you to pause the video and you try it. What if I was to give you 50? I'm sorry, let's not do 50. That's not a correct sign. what if I was to give you, let's say 6 times 10 to the 8th power divided by 2 times 10 to the 4th power. Alright, you pause the video, you try it, and then come right back and see what we got. Okay? Alright, welcome back. Maybe you have solved it. Let's see what we got. So remember, we're not going to regroup it this time. We're just going to draw our lines. I'm going to divide here. I'm going to divide my coefficients, and I'm going to subtract my exponents. So 6 divided by 2 is 3. Base is going to be 10, and 8 minus 4 gives me 3 times 10 to the 4th power. If it's in scientific notation, leave it there, that's fine. Let's go ahead and move it. So my decimal is here. I'm sorry, the decimal's here. Let's just add 4 zeros. 1, 2, 3, 4. So my answer is 30,000. Alright, let's try one with dividing. We have to do a little adjustment on my coefficient. What if I was to give something like 7.2? Let's back up. Hold on. What if I was to give 3.6 times 10 to the 8th power divided by 7.2 times 10 to the 6th power? Same concept. We're going to divide, and we're going to subtract. Alright. So remember, this is my numerator. This is my denominator. So the numerator goes inside the division sign, 7.2 on the outside. Alright. Just like we did a while ago, you have to move your decimal here on the outside, which means I have to move it on the inside. 72 will not go into 36. So we're going to add a 0. Let's see how many times will 72 go into 360. Well, I know if I estimate 72, 36, I'm going to try 5. Let's just see. 5 times 2 is 10. Carry my 1, 35, 36. Look at there, I got lucky. Alright, so my coefficient is 0.5 times 10 to the 8th power minus 6. So 0.5 times 10 to the 2nd power. But when I look right here, I see something that needs to be worked on. This number is smaller than 1, so we've got to do a little adjusting to where my coefficient is bigger than 1, equal to 1, but less than 10. So I'm going to move my decimal from here to here. Now it becomes 5 times 10, but since I moved it to the right, I've got to subtract 1 to the 1st power. And then we have 5 times 10 to the 1st power is 10, which gives me 50. Okay? So all you're doing is just moving your decimal one place to the right. So that was that answer. Okay? All right, let's try one and you do it and pause your video and then you come back and try it. Okay, let's see 3.8 times 10 to the 7th power. Let's do it this way. 1.9 times 10 to the 11th power divided by 3.8 times 10 to the 7th. Alright, you pause the video, then try it, and then come back and see what you got. Alright, welcome back. Remember, we're going to divide here, and we're going to subtract here. Okay? So 1.9 goes inside the division symbol, and 3.8 on the outside. Move your decimal, bring it up. 38 will not go into 19, so that's going to be 0. Alright, so add a 0, let's bring it down. Let's just pick a number, 38 into 190. So let's see. Let's try 5 just to see what's going to happen. 5 times 8 is 40. Carry your 4. Look here, I got lucky 2 times in a row. I got it on the first try. Alright, so I have 0.5 times 10 to the 11 minus 7 power, because numerator minus denominator, gives me 0.5 times 10 to the 4th power. Look right here. Coefficient is too small, so we've got to adjust. Move your decimal, subtract 1 from your exponent. So 5 times 10 to the 3rd power, which would give me, adding 3 zeros, 1, 2, 3. Now I can say that, add 3 zeros, because the decimal is back here. So just add the 3 zeros. Okay, you can't do that every time, but just make sure if you can do that, just add it. Okay? Alright, let's look at what we did in class. I'm going to do one more, then we're going to stop. What if I was to give you something like this? About, again, please excuse my writing, about how many times bigger is 1.9 times, let's not do 1.9, let's do 1.4 times 10 to the 8th power than 7 point, let's do 7 times 10 to the 5th power. So how many times bigger? I want to know how much bigger this number is. And again, I know it's bigger because my exponent is bigger. So remember, 1.4 is going to go inside the parentheses, 7 goes outside. So if I look at this, it's the same concept. All you're doing is setting up that same division problem. 1.4 times 10 to the 8th divided by 7 times 10 to the 5th. Alright? So 7 goes into 1 0 times. 7 goes into 14 2 times. So that's 14, 0. So I have 2 times, 0.2 times 10. Same thing I'm dividing here. 8 minus 5 is going to give me 3. So I know I need to do a little work here. So move this to the back. Move it one place behind the 2. To the right, subtract 1. So 2 times 10 to the 2nd power, which is 2 times 100, or just to do that, just put 2 zeros. Now, remember the sentences we wrote in class today. All I want to do is make a comparison between this number, and this number. Remember we talked about ACEs today. Answer, cite, explain, summarize. Well, your summary is going to be a summary of those 3 things. So if I was to write this sentence, I would write my sentence 1.4 times 10 to the 8th power is 200 times bigger than 7 times 10 to the 5th power. And that's what we're looking for right there. How many times bigger? Remember, times bigger, times larger, times farther. Anything that says that tells me division. Alright, let's try a word problem. Ready? Let's see if we can make one up like we did today. I know this is getting kind of long, but just bear with me. Batman can drive. Batman, the Batmobile. Let's back that up. The Batmobile can go 4.2 times 10 to the 6 miles per hour. That's pretty fast, isn't it? Okay. Wonder Woman's jet invisible jet can go or can fly 7.9 times 10 to the 9th power. Okay, what I want to know is about how much faster. About how much faster is Wonder Woman's, I'm going to abbreviate, Wonder Woman's jet than the Batmobile. And again, y'all please excuse my pen. This thing is not working right. I know I'm trying to write kind of fast, but it's still not working right. Okay, now look at this one. This one's different. Remember in class we set up today, we always set up, this was my first number, this is the second number. But remember what it's asking me now is talking Wonder Woman over Batmobile, because it wants to know how much faster Wonder Woman is. So when you set this one up, you've got to do a little reversal. We're doing Wonder Woman divided by the Batmobile. Okay? So when we set this one up, now it's going to be 7.9 times 10 to the 9th divided by 4.2 times 10 to the 6th. Now this may not come in right, so we're just going to estimate this one to the nearest 10th or 100th. We'll see what we got. Alright, so remember 7.9 goes inside, 4.2 goes outside. Cannot have this number right here, so with a decimal, so we got to move it. So if I move it one place on the inside. Now, 42 will go into 79 without going over one time, which is going to give me what, 30, 37, not 38. Okay. All right. So now let's add a 0. Let's bring it down. Now 42 goes into 170. If I'm estimating this, 40 goes into 37 9 times. I think that's going to be too big, so let's try 8. 8 times 2 is 16. Carry my 1. 8 times 4 is 32. That's 33. So 10 minus 6 is 4. 6 minus 3 is 3. So we're good. All right. So let's do one more, and then we'll round it up. So if I add one more 0, bring it down. 42 goes into 340. Let's kind of guess. We'll say 370 was 8. Let's go 40 goes into 34. Let's go 7 times. If I go 8 times, let's try 8 again. We know it's 8 because here it is. That's going to be 336, which gives me the 4. All right. If I was to round this up, 1.9 times 10, you're dividing, so subtract your exponent. So 9 minus 6 is 3. Alright, so 1.9 times 10 to the third power. This tells me to move my decimal 3 places to the right. So 1, 9. So 1, from here to here is 1, 2, 3. 1, 2, 3. Alright, so if I was to write my sentence, okay, we can say Wonder Woman's jet can fly about 1,900 times faster than the Batmobile. Sorry, y'all, this is terrible. I'm sorry. Can drive. Let's back there. That's terrible. Batmobile can drive. Okay? So if you're looking at that, that's what we're looking for here. Wonder Woman's jet can fly about 1,900 times faster than the Batmobile can drive. Okay? This is the key. And y'all, I'm sorry again for this pen. It's kind of a combination of my writing and this pen. But you get the gist of what we're trying to do here. Okay? Alright, so try the one on your homework, and let's talk about some more in class tomorrow. Okay? See you tomorrow.